talk today, and the talk will be on using R for psychological research. So I'm looking forward to what she will talk about, and I understand that there will be also some practical coding hands-on experience, which is very nice. So yeah, if you have any questions in the meantime, you can include it in the chat or later as well. But the floor is yours. You can maybe share more guidelines.
Definitely. Thank you. So, hi everyone. I'm Divya. I'm finishing up my PhD here in clinical psychology in Freiburg. A little more on that in my presentation, of course, but just to let you know, I've submitted and waiting for my defense date like we just spoke a few minutes ago. And I am working as a psychologist with children with neurodevelopmental disorders. More on that in the presentation as well. I'm just going to share my screen now so we can start off. Okay. Oh, sorry. There we go. Okay. So yeah, we're going to talk about psychological research today, or research in psychology, more clinical psychology because that's where I'm from, but I'm going to keep it more general as well so everyone can relate to it. So first of all, any psychologists in the house, if you could just briefly let me know what do you work on, and for the non-psychologists, what do you think we work on? Briefly in the chat, just so I have an idea of where everyone's coming from, where we stand.
Okay, I have a master's degree in social psychology. Mm-hmm. I'm not involved in research currently, but that's my background, like theoretical backgrounds.
Yeah, well, social psychology is very interesting as well, but that's also a field that should really start using R more because of all the reproducibility problems in general psychology. But yeah, I think social psychologists are also
so someone is
working.
Sorry, someone is doing the judgment and decision-making research.
Oh, nice. Yeah.
And they're not able to talk, but as it's before 8 a.m. there.
The ones doing judgment and decision research, could you give me an example of the task you use? Just what kind of task do you use for it? We could use it as an example later. And anyone else? Non-psychologists, what do you think we do? What do you think a degree in clinical psychology means? What do you think a degree in social psychology means? I have the South Park gif there.
I think that, oh yeah, so now we got an answer. So she's doing mostly judging acceptability of behavior change techniques at the moment. Okay. Scale-based answers.
Oh, okay.
And used a lot of reaction times in the past.
Mm-hmm. Yeah. Okay.
Anyone else? Well, I'm a non-psychologist. Maybe I can sure. Express an opinion. I think that you're doing something very, very individual level, like something that what people think, how people think.
Mm-hmm. Yeah. Individual is one of the levels, yes. Okay. We're going to briefly talk about that as well. Okay. If there are any more answers, keep them coming, but I would just move on because of time pressure. Okay. This is an example of my own research. If you look at this painting, what do you see? Like, what is the first thing that you looked at?
Well, men entering the room, obviously. Mm-hmm. And I don't know.
And then where did you look? So if I were to track your eyes, which is what I do, I work with eye tracking. If you first looked at the man entering the room, where would you look next?
Next is the reaction of the people in the room.
Mm-hmm.
Woman standing, kids gazing at the man.
Yeah. So this is an example of a free viewing task. This is one of the very first eye tracking studies done. This is not an example from my own study, but like an ancient study already, but one of the pioneers in eye tracking research. And what you can do with these kind of tasks, this is called a free viewing task, is you just show a picture and tell people to see wherever they want to, and you track their eyes while they do that. So if you look at the man, and then you say, look at where the man is looking, this is called joint attention. And so you say, okay, I first saw person A, and then I saw where person A was looking. And this joint attention lets us see certain pathological patterns or certain patterns that may be missing or not. Because of free viewing tasks, we've been able to identify things like, oh, you tend to look in the center first and then to the people. You can measure things like, do you look more at the people or do you look more at the paintings behind? Like, what's more interesting to you? And this is like the most basic kind of free viewing eye tracking task there would be. A little more complicated once we move on from here. Again, an example of a task we use in clinical psych. Can you still see my screen? Yeah, okay. Yeah. Here, your task is to find this object within this frame here. This is called an embedded figures task. Again, this judges something called local global processing. So how detailed can you process? How easy is it for you to look at the details in this global picture? So take a minute, tell me where you find this in the picture here.
In the middle?
Mm-hmm. Yeah. So, this part of the cube is the yellow, and then you can see it go behind there. Yeah? Can everyone see it? A thumbs up reaction would be great as well if you can see it.
I don't see it exactly.
Oh, okay. So look at this bit here.
Yeah.
And that's the yellow here.
Okay, yes.
And then this here is here.
Yeah. Now I see it.
Yeah. Okay. Same thing with the triangle. Do you see the triangle in the carriage? That should be slightly easier. So the triangle, like here, for example. This triangle is here. Okay. I see a few thumbs up. All right. So this is called an embedded figures task, and this lets you study something called local versus global processing. That's another thing that I study as well. And I said I work with, neurodevelopmental disorders, which is ADHD and autism in my case. And these kind of tasks is something that children with autism are really good at. So they can really see the local elements of a figure much better than the entire gestalt of a figure. So these kind of tasks also let us look at group differences. So autism versus ADHD versus typically developing versus a comorbid group. And that's kind of what my research is about. That doesn't mean that all clinical psychology is like that or all of psychology is like that, but it would give you a good insight into the kind of variability of design we can have. And I said I work with eye tracking. So this is actually from my example, like my study. You have to find this word in the grid below. Can you see where it is? It's similar to the embedded figures task in the sense that you need to look at a global, local thing in the global grid. Okay.
So second row, or and
third.
Insert
yeah, sorry, yeah.
So now I'm gonna so now I'm gonna play a video, and the video will have lines and dots. The circles are fixations, which means that's where your eye is focused on, and the line is when the eye is moving. And the bigger the circle, the longer the duration. So that's how long you were looking at the point you were looking at. So that's where it starts. So do you see how the eye is moving? That's where they found the word. They went back to probably check it and stayed there. Yeah. This is one example of an eye tracking study, and this is like my own studies. So you have a participant that starts here. This is a fixation outside the stimuli canvas. So they have to start there. Then the stimuli comes on. You see these smaller fixations, so small durations of the eye focusing somewhere, because they're like, oh, nope, this isn't the word, 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 this is not the word, this is not, oh, wait, maybe this is the word. And then they go back like, oh yeah, this was the word. And was it the word? Yes, it totally was. And then they press the key. So that's how you can see an entire process of cognition. So what's happening, how do you arrive to an answer by using something like eye tracking. So you have these 7 seconds of data. But now just visualize you have this 7 seconds of data times 30 per participant. I have 30 participants in each group times 4 groups. So that's how much data I have. You know, each trial has all these eye movements. Each person has 30 trials. And because I have 4 groups, I have around 100 participants. Yeah. Just to show you how complex this can get really soon, I have on the next slide 4 participants, just 4 on one trial. So imagine this will be 100 participants on 30 trials. Each is in a different color. Okay, so now what Lily said with individual level variability, where do you see it? Do you see any individual differences just with these 4 people?
Well, it's difficult to say the individual differences, but a few, yes. So some join a bit later to the star word.
Brown is a bit different. The pattern of brown.
Sorry,
the brown one is, I think, is different. Maybe.
Could be. The brown one is also different in how it looked for the word. Everyone went vertically and he went horizontally. And Lily, you're absolutely right. They reached the word, they found the word at different times. They also entered, like they started looking for it at a different time. Maybe some of them went directly to the word, some of them had to check the word. The blue one, for example, went like crossed the word twice and was like, oh, wait, was that the word? Was that the word? Came back to it. So without getting into too many details about how this analysis is done, because then it would be very eye tracking focused, there are these kind of individual differences, and eye tracking is just one method that I use to look at it, but psychologists can use anything. So you may have, like the other person in the chat said, she's using surveys, you're using reaction times, you're using, like I could also just take reaction time for this. I could just remove eye tracking and say, just press the key as soon as you find the word, and I would have a reaction time measure. You can have different kinds of designs. You can have open-ended questionnaires. You can have just an interview. You can have surveys. So there are lots of different ways how you reach this. But at the end of it, there are certain cognitive insights that we are looking for, and we are looking for them at these different levels. So in the first one, you saw like within a trial, so that's an inter-individual level. Here you see individual differences, and then you can also see group level differences. So that's where we come to. So you have intra-individual differences, individual differences, and group differences. So if I have 4 groups, then I can also compare the groups. I can run ANOVAs, or if I don't want to go that traditional, some Bayesian stats. And I have cognitive constructs, so I'm looking for attention, perception, memory. So I'm looking for what you attend to, how you perceive it. If you do attend to something, does it take time? Does it not take time? And you can have memory tasks. So I can show you something, take it away, and then be like, now tell me, where was the word Esther? Who remembers? And then you could say, yeah, I remember. It was in the second row, third column. Was it? Yes, thank you. It was in the second row, third column. Yeah, so that's what we're learning. Are there any questions till now? Did you think of any studies, any other studies that came to your mind? Maybe something you saw in the media recently, or do you have questions about what this kind of data would look like, or any other parameters you can think of?
I guess my first question would be, how much is the maximum sort of cases or individuals you are usually looking at in this kind of data sets?
Because I'm looking at clinical data, it's not as much. It's not more than 30, 35 in a group, which also takes me around a year to get. So I've had around 110, 120 participants in all. And then once you start cleaning data, a lot of participants have to be removed, a lot of trials have to be removed. It's not always as clean, so you need a little extra data anyways. But yeah, I mean, even if I take everyone I can possibly find with autism in my small town of Freiburg, it will not be as many, like not more than 30, 40 in the age group that I'm looking at. Anyone else? Yeah. Then I can move on. So, so we come to like what I said earlier. What psychologists do is we do quantitative analysis, sure, the kind that I showed you, but also interviews, surveys, questionnaires, and a lot more. And the thing that I showed you was just the first bit here. So wrangling and transformation. I mean, that's what I had to do before I did some visualization. And once I have my between group differences, I would model them to see if there are any significant between group differences. However, that's not all you can do in R. There is a whole lot of stuff that you can do. Imagine you're doing interviews and now you just have like lots and lots of text. So people have just told you, you asked about, you're looking at, let's say, a group of people with depression, and you've asked them about any recent traumas they've had. And they start telling you about this. And now you have an entire case history and you have their interview, and all of this is text. You could also do text analysis in R. Imagine you have a global survey. So you have a survey from like everyone who, let's say, COVID responses all around the world. And now you have this survey all around the world, and you want to relate this to how different countries were in lockdown or weren't in lockdown. And this would allow you to do, like, I would allow you to do some geographical analysis and plot it on a world map and be like, oh, here's the relationship between countries that had the number of COVID cases, were in lockdown, weren't in lockdown, mental health resources, lack of mental health resources, and you could plot this geographically. So visualizations don't just mean having a graph or having some kind of a plot, but you can also have geographical analysis. You can have fact analysis if you're making questionnaires. So, you know, if you're building your own questionnaire, you can't just be like, oh, I think this question is nice, and this question is nice, and this question is nice, I'm going to ask this. You would probably have to come up with a long list of questions, pilot it, and then do a kind of fact analysis to see which questions you would keep in this questionnaire finally and not, based on reliability and validity of the different questions. So you can do fact analysis in R as well. You have very specific packages. So you do have packages for eye tracking. I didn't use them. I stuck to base R, tidyverse for most of it. But you do have packages focused just on eye tracking data, which allows you to look at areas of interest. So you have like, oh, in the man entering the room, I want to see when they looked at the man. And you can just mark the man as an area and then be like, tell me the fixations where the man was looked at. Those kind of packages would be available in R as well. EEG data, a lot of psychologists use EEG data. You need a lot of cleaning that goes on in EEG and stuff as well. You have those kind of packages. Twitter data as well. So if you want to just look at, if you're a social psychologist, let's say, and you want to look at Twitter responses or trends on social media, you can do Twitter analysis very easily. And actually, if you go to R-Ladies Freiburg GitHub, I've already taught Twitter analysis. My co-organizers have taught text analysis and geographical analysis. There's another one happening in 3-4 days. Like Wednesday, we have another meetup on geographical analysis. So there is all this data already available. Thanks to COVID, you can now even, I'm presenting in Georgia, and you can also look at what others have done. Yeah, and finally, Markdown is really, really good, and there are meetups on Markdown as well available online. You can write your tables, APA style, your reports. You can do all of this and just integrate it with your R code. So you can just start writing your method section, integrate the tables, integrate the figures, and this makes it a lot more reproducible as well. You can, if it's in Markdown and someone says, hey, how did you do your methods? I don't know, I don't understand this. You can just send them your Markdown file. It makes it a lot easier for people to replicate your research. And if you're just not interested in staying in science or staying in academia and doing science, blogs are a really good way in Markdown as well. So there are all these different things that you do as a researcher in psychology, and R kind of lets you do all of it in one place, is what I'm trying to get with this slide. Any questions up till now? Anything about, yeah.
There was one question about how were you able to track people's eye motion?
Oh, sure. There are eye trackers available in the lab or in the field. So you have lab eye trackers where you just put this tiny box, like a sleek box, under your monitor, computer monitor. And the sleek box has basically infrared and cameras. The infrared tracks your eye, and the camera then tracks where the infrared is tracking your eye. And that's how, that's how you do it. Let me just see if I can, I'm just going to stop sharing for a minute because I definitely have a picture of this. Are there any other questions in the meantime?
So I guess if you have study participants, they are all aware of these measurements and
definitely.
Yeah. Mm.
Yeah. Okay, I'm just gonna start sharing my screen again. And there we go. So can you see it?
Yeah.
Yeah. So that's an eye tracker there, right here. That's where the participant sits. And the eye tracker is connected to a computer outside. That's how the tracking's done. Also, that's a funny picture of me wearing a mobile eye tracker. So in this case, here you have the camera, and there are infrared lights on 3 sides in this model. And that's how you can just wear this, take the laptop on your back and move around, and you can even do field studies. So you can do studies. Yeah, so you can do studies on the go. You can ask people to go look for a book in a library, and that would be equivalent to looking for a word on the screen. But because of the mobile eye tracker, you could walk around a library looking for a book. Or consumer psychology uses the mobile eye trackers a lot, and you can just ask people to pick a cereal, and then you can look at them choosing a cereal, looking at the box, see what interests them. Is it the packaging? Is it Is it the ingredients? Is it the calorie content? And so consumer psychology uses a lot of this as well. Yeah. Okay, anything else? Okay, then we can go on. Okay, everyone has their data set, I guess. Just wanted to let you know before we start, I got the data set from Kaggle because my data set is all clinical data and I can't really pass it around, and I didn't want you to start with eye tracking data if this is your first time interacting with psychology data at all. But if you go on Kaggle and search for mental health data, you have that many results. And these are just like a few of them. There's also something on COVID, there's stuff on suicide rates, there's stuff on happiness index. If you just, excuse me, if you just want to practice, you can just look at data sets and see what's available for practicing. Today, we're going to look at mental health in tech survey. It's a survey, so it's, yeah, already sorted into columns and stuff, which is a good start. And it's mental health in tech. I thought maybe a few people who've joined us are more into tech fields and would be more interested in such topics rather than just general economics and happiness ratings and stuff like that. So yeah, first I would like for you to just open the data set, look at it. I assume there's no one here who's never used R before. If they are, just like, just let me know and we can do that together as well. But first I would just like to talk to you about the data. Like, what do you see in it? What do you think would be interesting factors? What do you think would be interesting to analyze? If people have already started looking at the data, just give me a thumbs up so I know who's done, who probably has some trouble with it. Okay. I see a few thumbs up already. So the ones who started or who can see the data, what do you think? What would be interesting to look at?
Mostly it is categorical data.
Yes.
About work and mental health. And we can try to find correlations or make models about assumptions, what might be the connection between, for example, age, gender, type of work they do, whether hey, what's the status of the family, how many employees there are in the company or wherever they work, and so on. I mean, we can compare this categorical data to status of the mental health, I think. Yeah,
that's a very good start. You could also, just to let you know, if you go to the Kaggle link, in the description, you have a description of what each variable means. So what question was asked to record that variable. Now, I guess some are self-explanatory with like how large is the company or age or where they're from. But some of the other variables are a little tricky to understand just by looking at the name of the variable. Anyone else have any ideas or any questions?
So would it be, if you're asking what to study, or what are the ideas like that come up?
Any ideas that come up, even problems, because the data does have a few issues as well.
Well, there seem to be quite several missing values for some variables at least.
Yeah.
That might be a problem.
Yeah. Definitely. There's also, have a look at the geographical data. Like if I wanted to analyze this by country, that's also going to be an issue. Each country has been written in different ways, different names. I would first have to look at all the different ways USA has been written or Canada has been written, capital, small. So it would give me a lot more factors than there actually are. No? Capital USA would be registered as a different factor than small USA, than United States of America, than U.S.A. So there are all these variables that I actually wanted to look at geographical data and I wasn't able to. I mean, it didn't make sense to spend another 10 minutes showing you how I cleaned the data first.
Yeah, same in the gender column.
Sorry?
Same is true for the gender column. They have male
okay.
to and just a single character M left.
Yeah. Yeah. Also, if you go look at statistically, I mean, if you had to do a model here, I guess gender would be fine, but there aren't, there's like a lot of discrepancy in how the data was collected. So there are a lot more people from one group than from another group, and there's no theoretical reason why that should be. So if you just had to run a model on some of these factors, that would also be an issue. Yeah. But what could be some of the things we could study? If you're looking at the questions, maybe I could
so there's also a question if we can use R in some way to analyze comments section. I'm not sure if...
Definitely, you could do some text analysis on that and analyze comments for sure. So I'm sharing my screen here again. So if you look at these, that's on Kaggle, and these are all the parameters. Maybe make it bigger. What do you think would be a good correlation? What do you think, what relates well to another factor? Come on, people. You don't need to be a psychologist to do. Yes.
Hi.
Hi.
Maybe it's about work-life balance and something like that also.
Definitely. Definitely. What would be your factor for work-life balance? So you have, what factors can you take from here if I wanted to measure work-life balance?
For example, remote work and control for whether employer provides health benefits and outcome like mental health state.
Yeah. Perfect. Go ahead and run the regression. So I'm serious about that. I mean, this is your hands-on work. You have my script as well, and I, in a few minutes, can show you what I found was interesting and what I wanted to look at. But if you have an idea like this, work-life balance, and if you feel confident enough to run a regression, then just do it. All you would have to do is turn it into like maybe a number from like factorial to numeric, and then just run a regression model. It's like 2 to 3 lines of code. And if you need any help, just let us know. And I can also help you out and show you where you got stuck.
Yeah, thanks a lot. I just can't. I was trying to open CSV file, but somehow my R doesn't want to open it. So I guess I'll just listen and follow.
Yeah.
Yeah, thank you.
No worries. Anyone else have any ideas? What about mental health issues? There are a few on mental health issues, like family history, seeking help. If they would bring up a mental health issue in an interview or not.
Or if your employer has a program for this wellness program, if it's a work-related focus.
Yeah. Okay. Maybe I could share what I have already done, and maybe that gives you some more ideas.
I was just wondering if it might be like if the CSV file doesn't open, then, I mean, I'm not sure what the problem was, but maybe it would help to just import it as a CSV, to use the import function if nothing else works.
Also, if my CSV doesn't work, you could just download it directly from here, from Kaggle. Maybe it's just like somehow corrupted while sending it to you or something. But you could just download it from the website. Wait, let me show you where. There, look, that's the download. Quick show of hands. Are you familiar with this website? Have you downloaded data sets from here? Just thumbs up if you have at some point.
Oh, I just used to download this data, this one.
Yeah. Also, if you, I just sent you my script, but I wasn't intending on my script to be used right now because, of course, my working directory is not set to something like GitHub. So you may have trouble if you use my code. Just make sure your working directory is right, and where you say import CSV, you've written everything, like the path is written correctly. Like my script just uses my working directory. So just to quickly show you what I've been doing. So once we import the data, look at it, we've discussed it a bit. For me, I just wanted to look at how easy it is for people to take leave for mental health. How easy would it be? I mean, if you look at the question, it kind of means how easy would it be for you to go to your supervisor or go to your boss and say, sorry, I'm taking a sick leave because I don't feel good emotionally, mentally. That's something people hesitate to do. That's something I hesitate to do. And I work with psychologists. I mean, my boss is a psychologist. And I don't think it's that easy for me to just go and be like, I'm just going to take a mental health day. And that's quite problematic because that's how you reach burnout. That's how you have increased symptoms of depression, increased symptoms of anxiety. If you just stopped in time, sometimes it's helpful. And so the variables that I've selected are related to this. So it's like, I've only taken first the tech companies because there were a lot more tech companies than non-tech companies. That's what I meant by if you had to run an ANOVA or something, there would just be an imbalance. Like there would be a lot more tech companies than non-tech companies. So I just removed all the non-tech companies. And then I looked at the benefits provided by the company. If you were open to seeking help or not, if you would apply for leave or not, if you're open to talking to co-workers about mental health problems, if you're open to talking to supervisors about mental health problems, evaluation of mental versus physical problems, and I'm not sure what observable consequence was anymore. We can go back here, look at it and say, what was observable consequence? Have you heard or observed negative consequences for workers with mental health conditions in your workplace. This would also influence, like, if somebody else did this and you saw the boss being like, they've taken another leave because they have all these mental health problems, and this coworker who is depressed and needs to keep like taking leaves or working from home, then you are less likely to do it, is what I thought. So you have all these hypotheses in your head, and I'm like, when would people be open, or what kind of an environment would be open and welcoming to people saying, I need a day off? And I need a day off not because I hurt my leg, not because I have a fever, not because I have a physical symptom, but because if I don't stop now, I probably will have a physical symptom, you know? So that's what we looked at. Okay. And then I just looked at all these columns. Here I've used the sapply function to turn them all to numeric. They were all coded as yes, no, or yes, no, maybe, or like they had up to 3 levels of yeah, maybe, not sure, and they were all coded differently, so I made it all numeric. And then I ran a correlation table. So you could just see the correlation table. I could run it in R, but it's just like a whole lot of numbers and it gets overwhelming. So what I'm going to show you on the next slide is actually a correlogram. You can make it with this package here. It's the simplest way to visualize a correlation, and I'm showing you this because you don't have to be a psychologist to do this. You don't have to be like doing eye tracking research with ADHD and autism to use something like this. You could just be doing any kind of survey and you want to look at a correlation. And here you see this being very high positive correlation, very high negative correlation, and here are all the factors I chose. And you see there's a high correlation between the benefits offered and if you're likely to seek help. So companies that are saying openly, hey, if you have a mental health problem, we are willing to give you leave. We are willing to pay for your therapy. We are willing to invest in your mental health. You're more likely to ask for mental health help. And there is a very high correlation between if you are likely to talk about your mental health problems to your coworkers and to your supervisor, because obviously if you're talking to your coworkers, you're not talking to your friends about it. So if your coworker at some point in a meeting is like, oh yeah, they aren't in today because they had a panic attack this morning, your supervisor will know about it. Or if they're like, yeah, I wouldn't give person XY this project because I don't trust them to do their job well because they have anxiety. Your supervisor will pick up on these hints, you know. And so obviously the entire work dynamic and your work environment is based on this kind of correlation. Now, I'm a clinical psychologist. I'm sure industrial and organizational psychologists would have a lot more to say about this correlation. And what I'm going to show you on the next slide. But this is like some starting point for you, and this is like something related to mental health that irrespective of where you're working, you could think about, am I stopping myself from seeking help? Am I looking at people who are seeking help in my surroundings a bit differently? And how does that influence my own work atmosphere? So yeah, any questions about the script or anything till this point? Otherwise I have one last visualization.
I had a problem with running the correlation table actually, but I don't know if I just did it so fast because I did the numeric. I made the numeric.
Yeah.
And then when I ran the correlation table function, it somehow said that this object was not found. So maybe I need to do some extra step to have this as an object.
Could you show me your script, or did you just run my script?
Yeah, I just ran your script.
It worked for me actually. I don't know.
Oh, okay.
Yeah, so maybe I have to focus on something else.
Should I run my script again and show you how it looks like on my screen?
Well, I don't know. I mean, it's you can try.
Is the Do you have a new data frame called Select MH survey?
I didn't, so maybe I have to do it into a new data frame.
Maybe that was the problem, because sometimes
Yeah.
sapply just works because it's like, sure, I'll apply it on columns that don't exist.
Yeah.
There's no error there.
Okay, I'll try it again.
Okay.
And I will see.
Try that.
Thanks.
Okay.
I would have one question, if that's okay.
Of course.
So when we don't have numeric variables and like yes, no answers and so on, my experience is that the last time I tried to use Cramer's P and V coefficients instead of like regular correlation coefficients, and is that okay, or can I just make numeric all the time, no matter what type of data I have, and run this type of correlation? Thank you.
You can't do it all the time. That's right. This is a relatively easy data set in the sense that I didn't see any problems. Like there were, when you run the summary, they very clearly had 3 factors, and the 3 factors were always the same. It was yes, no, maybe, or yes, no, not sure. And if it's that kind of a data set, then I don't see a problem with just turning into numeric. But you're right, it may not always work, especially when you have, when it's, I've had a problem with turning into numeric with certain factors. I think I also had a problem when the groups themselves were called 1, 2, 3, 4, and then I turned them into factor because I wanted to run an ANOVA on it, and then when you go from numeric to factor, and then you want to run a correlation or something, and then you want to turn it back into a into numeric, at some point it does create issues. My way of going about it is just simply checking at every stage. I wouldn't say use X or Y all the time, or like use one over the other all the time. I do find a certain ease with converting things to numeric, especially if you're using something like sapply. But yeah, just keep checking if it has actually done what you want it to do. I have had more problems in turning to factor as well. So yeah, I would just say keep checking and just make sure you are actually doing what you want it to do, and R is doing what you want it to do.
Thank you.
Thank you.
Excuse me, can you just very briefly describe this sapply function?
Sure. So what it does is you select all these columns, and it just applies in this. So that's the data frame. That's the selected columns. And you apply in this data frame, in these columns, to numeric. That's it.
Okay, thank you.
Yeah. Okay, anything else? Should I move on to the last bit?
And just a question, so this GG core plot is part of the ggplot package, or?
No, it's a separate package.
Oh, it's a separate one. Okay, yeah. Then I have to find it. It's not finding it.
Oh, no.
I will search more.
Oh, sorry. I thought I wasn't using any fancy packages. I thought everyone would have tidyverse. But that's right. I am using one extra package.
It's okay.
Yeah. Okay, that's the last one. Here, again, I wanted to see how stigmatized mental health was. So you have the co-workers question and the treatment question. Does everyone remember what these questions were, what we chose, or do we want to go back quickly and look at it? We are doing a survey.
Let's go back.
Let's go back. Okay. So you have treatment, which says, have you sought treatment for a mental health condition? And you have co-workers. Would you be willing to discuss a mental health issue with your co-workers? Yeah. So basically, if you've sought help for any kind of mental health problem, would you be willing to discuss this with your co-workers or not? And here I thought, hey, at least people who've gone that extra step and found a psychologist or a psychiatrist and seeked mental health, or even if they just went to a counselor or just spoke to a friend about it, if they if they sought any kind of mental health help, they would be more open to talking about it than people who didn't. I mean, they've already made the first step. They've already spoken to somebody about it. But here I was also, again, very surprised that there were like seemingly no significant differences between people who had sought mental health help and people who hadn't sought help. They were just as likely to, I mean, sure, there's a slightly higher yes here, marginally, but most, like, the bars look kind of similar. And I thought this was quite interesting because the resistance is the same in both groups. And so if you, and it seems to be something with the organization culture in itself and not more individual differences between people who are likely to seek help and people who aren't likely to seek help. So this is also an example of how you can integrate your individual difference knowledge with an organizational level knowledge, or in other cases a group level knowledge, to be like, okay, wait, there is this individual difference and I see that there is a group culture. So, you know, in the correlation, I see that there is this group culture and that there is this group culture. So organization definitely plays a role, but how much does an individual play a role? And here I would be like, oh, but there is this one variable at least that is an individual difference, and that doesn't vary a lot based on yeah, I mean, the organization still plays a bigger role than the individual variable here. Yeah, and the way I've done this is just use a simple ggplot. I really like this color scheme. It's the Game of Thrones color scheme. I don't know how many of you are fans of Game of Thrones. The same creator or the same programmer also has a Harry Potter themed color scheme, and they're just very pretty schemes, actually. And yeah, so that's that. Any questions till this point? Like, this is the entire script. Any questions you have running the script? Anyone still stuck? Lily, could you get your correlation?
Yes, I did get the correlation. It worked now.
And I know you don't have the package for the correlogram, but maybe this worked?
I will try this one still.
Also, you may not have the Game of Thrones package, but
no.
You can just use a different color scheme.
Yeah, I will try this one.
Anyone else? Any questions you have about the script, about what I'm doing here?
So when you use this correlogram function package, can you test the significance in these charts, this correlogram?
Interesting. I haven't tried that in a correlogram, but I could look it up and get back to you. Like, I could send Lily an example if I find one online.
Because it comes from this ggcorplot package, right?
Yeah.
There's also a package for this kind of correlation, and it has this option suited in the test for the significance. So it shows you like which one of the correlations are significant statistically.
I'm sure there would be a way. Like, I don't see why not, because it, like, ggplot does that in its bar graphs and stuff. So I don't see why it should be a problem here. I'm sure there is a way where you could just change like from strength to significance, and the color then defines significance or something. I could look into it and send you a sample script once I find it.
No, I'll look it up for myself. Thank you.
Well, if you find it, you can just put it in the chat. I just don't want to be Googling things right now, but if you just find it, you can add it to the chat.
Yeah, and it worked for me very nicely. Even if I don't have the Game of Thrones library, then you can just, I think, delete the scale fill row, and then it will just use the default colors, and it works fine.
Yeah. Okay. Just before we finish, I would love to show you how complicated figures can get. So this is a figure from the eye tracking data that I showed you early on. And this is at the group level. So you have 4 colors are the 4 groups. And you can see in R, you can, of course, there are all these different variables, but I could also like move them around. So, you know, it's not just upright, but you can turn the axis. You can have different plots all together. And this is the aggregated group level data. Just want to finish it off with like, yeah, the group level data that you can have as well. And then you can see group differences. Okay. Think we need to wrap it up soon. So I'm gonna leave you with that. Any ideas on how we could progress from here? And I would love to hear how you would use R for, or R in psychology for your research, or if you got any ideas. And of course, questions are welcome.
Yeah, thank you very much. We do have some time for questions now, so feel free to use the opportunity to ask about anything, I guess.
Yeah, definitely.
Doesn't have to be necessarily about this this topic or this data set, but
yeah.
Okay. Can I ask a question?
Of course.
Do you do time series analysis in data? Like in this type of, so for example, we have here a date variable. We can do the analysis in terms of time series. Have you ever done time series analysis? And how is it different? Like, what are the specifics of the type of analysis that is different from the other kind of statistical analysis of the data?
So you could do time series analysis, especially with eye tracking data as well, because you have, I mean, if you have a sampling rate of say 500 or even 250, it means you have 250 data points per second. And if you look at the raw data, you could really do time series analysis there. Conceptually, I would say it's quite different in the way you look at data. It's quite different in the way you interpret this data, because now you're looking at the 7 seconds, you know, you're looking at 7 seconds per participant. And then you could say, for example, pupil dilation is something that you could do really well over time. So you could be like, how did pupil dilate after I presented gruesome stimulus? You know, I just showed a dead body covered in blood, and how did the pupil dilate after? And you could do this really well in time series analysis. You could also do it for a longer time period. So you could say, how were fixation durations different? When you look at this picture with the man entering the room, for the first second, was this for the first 5 seconds? Was this for the first 10 seconds? Or you could do time series analysis with, let's say, movement, and you're wearing like, what's it called? You know, the bands that measure wrist movement and how much you're moving your hands and legs. And you want to measure sleep. So you have like something you tie on the ankle or the wrist, and you let them sleep for 8 hours. And then at the end of 8 hours, you have 8 hours of data being like, how much activity was there at different parts of the night. So I think conceptually it's really difficult. But that's the thing I like about psychology research in R, is that once you have the concept, once your head is wrapped around what you're trying to find, actually running this is not a very difficult script. So once you have this data and once you're like, okay, this is what I want to plot, then it's just like plotting any other data set. Yeah.
Okay.
I would have one question.
Yeah, sure.
It's not directly related to this, but I study sociology. I'm doing my master's also in Germany at Free University Berlin, and I have never worked with experimental data, so it's my first time. And I was very happy actually when I found that R-Ladies was doing this workshop, and thank you very much. So I thought maybe I would have a chance to give this question to you, maybe with your experience, because it's not directly related. So I would have 2 groups, and my data is also not numeric data. It's like yes, no questions. And I was trying to find the method to analyze group differences. So I have one statement that I give to one group, so that's my treatment. And then I have another group that I give another statement, and I would like to compare group differences and also taking into account other variables. But I was trying to do it with Uncover, but then I realized because my dependent variable is dummy coded, it doesn't work. So I was trying to find any method for that, and I came across multi-level data analysis, but I don't know if I'm in the correct path. So maybe with your experience, you would have worked with data where you have everything dummy, and what kind of method would you use for comparing group differences? Yeah.
So on the first level, if I understood just your design correctly, it looks like a chi-square design.
Yeah.
Yeah, so I would say that's the test you need to run. Like you may have to go non-parametric and not use a parametric test. So you could look into non-parametric tests and probably the chi-square test. If you do want to look at multivariate coding, R-Ladies Freiburg, like my co-organizer, works with modeling. So there is data available on GitHub on modeling and different kinds of things, including Bayesian stuff. So maybe you want to, I don't think that's possible with dummy variables. I would have to check with the other expert in my group, but you could look at the modeling workshops and see if you find something there. But on the face of it, it looks like you need a simple chi-square to start with.
Thank you very much.
Welcome.
There's one more question about time series analysis. Which packages do you use and how do you test the differences?
I don't do time series analysis, so I couldn't tell you any packages there. How do you test if they're statistically different? Oh, that's a good question. I'm actually not sure. So I can think of a few ways. You could, of course, aggregate it in different ways. And then finally run the aggregates in a model. But you may have to also cut it into parts. So I don't think if you just took like, let's say the example with the 8-hour sleep thing, I don't think you could aggregate over 8 hours. That would just be too much. So you could break it into like different sleep cycles and aggregate across sleep cycles and then study that. That's like one thing that comes to mind. I could look at the packages and see if I find something. I'm also like used to EEG data, and in EEG data, we just look at ERPs then, or you aggregate it across a topographical area, and then you can like use the aggregate of the topographical area in EEG. Or you could use different markers. So you could say, I take it from the first time an event happened to the next time that same event happened, and then aggregate it across that event, or just take the peak value. So if I say the pupil dilation, for example, you could, of course, look at the peak dilation of the pupil, or you could look at the slope. So you could look at, like, you could measure the slope that it took to the dilation, so from baseline to the peak dilation, and then you take that slope and compare that statistically. So then you have like a beta value for the slope, for example. Does that answer your question?
I think so.
Yeah, it does.
There's also, just to remind you, it's not about a package, but it's, I think also in BaseR you can use some functions to do time series analysis. And we actually had also for R-Ladies Tbilisi once a meeting on this topic. It's probably quite in the beginning, so you might want to check our GitHub materials. It was given by, I think, Nino Melitauri. So you can check what she used if the materials are there, and it was definitely BaseR, I think.
Yeah. Well, none of my eye tracking data has been done in eye tracking packages. I've always used BaseR and some tidyverse, and that's quite versatile. And that's what I meant by, you just need to wrap your head around what you want to do, and then it's doable even without a package. Yeah.
Okay. Any other questions? Still have a few minutes. But if not, then we can wrap up. And I want to say thank you very much for giving this talk.
Thank you.
For showing us some code as well.
Yeah, hope everyone could learn something, trying to keep the level at the right place. But yeah, I had fun, and thank you for having me.
Thank you.
Yeah, thank you.
Thank you so much.
So I'll just also remind that we will have next meetups on the 14th of November and 28th of November, and they will be both in Georgian language. Yeah, keep an eye on them, on the announcements, and sign up for them. But yeah, thank you again, and bye.
Thank you and bye.